try and draw Spider-Man on here. Okay. So here is Spider-Man. And Spider-Man is swinging along, and he is attached to this lamppost with his spidey web. And as he's swinging, the web that he has attached to the lamppost is stretching. And so this is not a perfect circle the way that we had in our last example. And so the path that Spider-Man is following is described by this equation right up here. Okay, so every point that is on this curve satisfies the equation up here. 4y squared plus 4xy plus 40y equals 400 plus 80x minus x squared. All right, and so here's what's happened is that Green Lantern has come along and the Green Lantern, he's a good guy. Green Goblin came along and sliced the web that Spidey was using here, and so right at this point here along the path, Spider-Man's cable to the lamppost is cut, and he goes flying off. Now, physics tells us that if you're traveling along a curve and suddenly whatever is holding you to that curve breaks, you're going to fly off in a tangential direction. Okay, and you're going to fly straight in that direction. And so, in this case, what's happening is that we've got Spidey's new direction after the cable is cut, or after his web strand is cut, is going to be in the direction which is along the tangent to the curve at this point. And so our goal is to find the equation of the tangent line to Spider-Man's path at the point where Green Goblin cuts the web. All right, so that point where the web gets cut is right here. All right, so this is the equation of the tangent line. I mean, this back portion of the tangent line is also there. It's just not part of its path. And so we'd like to find the equation of this line. Now, the equation of any line, we need a point and we need a slope. And so our slope is going to come from slope for a tangent line, which is dy over dx. So to find the slope, we'll have to calculate dy over dx. But we also need a point. All right, so when I look at the picture, or when you look at the picture, negative 4, 2. Okay, so looks like our point might be negative 4, 2. Do I have a second on that? Okay, third, okay, fourth. All right, so negative 4, 2 seems like, it looks like it's pretty reasonable. We better make sure that we're right on target with this, so we better check that our point does indeed lie on this circle up, or this curve given by this equation. So we better check by plugging in x equals negative 4 into one side and y is equal to, or in for x and y equals 2 in for y. All right, so I'm leaving this half of the room responsible for plugging x and y into the left side of the equation, and I'm leaving this half of the room responsible for plugging x and y into the right side of the equation. And we'll see if those values match.